Hello everyone, so welcome to another video on further maths course in Edexcel first year, year 12. I'm looking to do today a video on chapter 4 for Edexcel book, which is the roots of polynomial. Okay, so there are really two types of questions in here. I mean, if you take algebra as one of the types, so there becomes three then, but normally there are two types of questions. Number one is when you prove and identify and use the relationship between the roots of quadratic, cubic and quartic polynomials. The relationship you're going to be talking about, people, can be extended to any other polynomials, but obviously we work on only these three. Okay. And the second type of the question, I mean, I'm going to ignore the type where we have to use some algebra on these roots. Second type is when you find or write polynomials with the roots as linear transformations of roots of another polynomial. Okay, mind my handwriting. I'll go over this one by one, then we take any examples from the book. Okay. All right. So the quadratic equations, polynomials, I look at these three types. Obviously, I'm using this as equals to 0 to make them equations so we can solve them. And the roots, I'm taking this as P and Q for the quadratic. Okay, P and Q and R for the cubic, and P and Q and R and S for the quartic. So guys, what are the relationships we want to talk about is this. Listen very, very carefully. This is important. Okay, if I say the sum of roots, so I get P plus Q here, I get P plus Q plus R here, and I get P plus Q plus R plus S here. What I can do, guys, I can actually relate these sum of roots to the coefficients of these terms, and the answer in each case is, surprise, surprise, is minus B over A, minus B over A, and minus B over A. So if you can identify your A, B, C carefully from this, okay, and somebody asks you, don't find the actual roots, but just tell me what's the sum of the roots, you can just do minus B over A. Okay, now in the simplest case, the quadratic product of the roots, which I'll say P times Q, and this will be C over A. Okay, now guys, what I'm going to do is I'm going to tell you all the possible relationship for cubics and quartics. With quadratic we have only these two. I'm going to write them here, then we'll try to generalize for you how do we memorize them and what kind of relationship they have with these coefficients. I'm going to write all of them first to save time in the video. Okay, so I'm going to try now. I'm going to try adding, this is what I write as sum of product of two, and I say it as two at a time. There are only two roots for quadratic, so that means this, we've done that. Okay, over here, taking two at a time, these are the three roots. This becomes P times Q plus P times R and plus Q times R, taking two at a time. Taking two at a time, what will happen here, people? This will be P times Q plus P times R plus P times S plus Q times R plus Q times S and plus R times S. Okay, and the answer is, have a look, guys, here. This is, we've used B and A, so it will be plus minus plus C over A. Here as well, plus minus plus is C over A. Okay, so look, the first term we used b is negative in both of them, in all three of them. C we used in all three of them, can you see? And C is positive, right? So this is the sum of the roots taken 2 at a time. Now I'm going to write sum of the roots taken 3 at a time, because this won't work here. Over here, sum of the roots taken 3 at a time becomes the product. So P and Q and R, and have a look at the equation, guys. You've used A already at the denominator. You use minus, plus, and minus. This will be minus T over A. Okay, so let's work this out for sum taken 3 at a time for Quartic. So guys, if we take 3 roots at a time and multiply them, and there are 4 possible combinations we get in Quartic, and the answer of, if we add all these 3, product of 3 taken 3 at a time, it will be, look, 3. So this is 1, 2, and 3. We're coming over here. So plus, minus, this is minus T over A. Okay, and finally, if you do taking all of them together, that means product of the roots, P times Q times R times S. We're going back again, we're coming to last coefficient, plus, minus, that gives you E over A. Okay, this is one thing which you need to know, relationships between these roots. Then we do a bit of algebra on this, but all you have to do is just, guys, memorize. How do we remember this? Okay, so all you have to do is just plus, minus, plus, check the coefficients, divide by A, all of them. Okay, and then this thing can be used to write the equations as well. We talk about that when we reach there, guys. Okay, this is the first thing I wanted you to understand. Okay, so let's go over a few of the questions, guys. This is a quadratic. You're going to find alpha plus beta, that is minus b over a, so minus 7 over 3. And you're going to find alpha beta, that is product, which is c over a, minus 4 over 3. Okay, I'm going to talk about this algebra part a little later, these C and D, so you can do it for this as well. Okay, you can do it for this as well, and we'll talk about this algebra part in a minute. So number 4, it says the roots of the quadratic equations are alpha equals 2, beta equals minus 3. Find the integer values of a, b, and c. So what do you need to do, people? Minus b over a equals alpha plus beta, and c over a equals alpha times beta. Make 2 equations, work from there. Okay, next one. Roots of the quadratic equation, this and this is these 2 numbers. Integer values will be the same thing, guys. Add these 2 together, the roots, then that will be equal to minus b over a, and times this root together, that should be equal to c over a. Make the equations, find the value of a and c. Number 8, given that kx squared plus k minus 3, this equation, and find the value of k if the sum of the roots is 4. So what you need to do is, guys, minus b over a, which is minus bracket k minus 3 over k, is equal to 4. Work out the value of k from there. Okay, and so on and so forth. Number 11, guys, have a look at number 11 now. The equation mx squared plus 4x plus 4m equals 0 has roots in the form k and 2k. Find the values of m and n. Okay, so sum of roots k plus 2k will be 3k, and 3k should be equal to what? Minus b over a, minus 4 over m. So you get one equation in k and m. Product of roots 2k squared should be equal to what? C, so 4 over m. That gives you second equation in k and m. Solve these 2 equations to find the value of whatever you need to find. Okay, then let's move on. Let's see, cubic, the same thing. Exercise 4b, what does it do, guys? Pay attention. This is alpha beta gamma, the roots. So you're going to find alpha beta gamma, that's minus b over a. Alpha beta gamma, this should be alpha a, b, c, d. This will be plus minus minus d over a. Okay, and this is taken 2 at a time. That should be a, b, c, c over a. Okay, and so on. The algebra part I'll tell you in a minute. Okay, you can work on these 3 from there as well. Select very carefully number 4 now, guys. This says the roots of a cubic equation, this are this. Find the integer values, which is the same thing again, people. You find the sum of the roots, means add these 3 numbers together. That should be minus b over a. Then you times a alpha beta, alpha gamma, beta gamma, add them together, taking 2 at a time. That should be equal to c over a. Okay, then the product of roots, multiply all 3 of them, that should be equal to d over a. So from these equations, find the values of a and b and c and d. So we work on this, guys. We're going to do question number 8 in here. Okay, question 8 of this exercise 4b. This is a good one, actually. Have a look carefully. It says the cubic equation. This has the roots alpha, beta, and gamma. If you can look at the question, write down the value of this. So this is what? Sum of taking 2 at a time. That gives you a, b, c. Should be plus, minus, plus. C over a is the answer. So which is 30 over 2, 15. Okay. Then alpha, beta, gamma, which is a, b, c, d. So plus, minus, minus d over a. That will be 13 over 2. That will be the answer for this. Then express k in terms of this, guys. This gives you the sum of roots. So alpha plus beta plus gamma plus gamma equals 2 minus k over 2. Work out to find alpha k in terms of alpha, beta, gamma. That's what it will be. K over 2 is equal to alpha plus beta plus gamma. So k equals twice of that. Okay. Then you're going to give alpha, because that's alpha, people, are very important. So one of the other roots will have to be the conjugate of complex number. We did tell you that in complex number chapter. Work out the value of k. If you can't do it, we'll work together later on. Okay. Right. So similarly, questions come in Quartic as well, guys. Similar questions. Now I'm gonna do some algebra of this. How do I work out these kind of questions there? Okay. I'll pick some questions now for you. Alright, guys, as promised, I will do algebra of this, because I've picked up question number 4 for exercise 4c. I'm going to do this for Quartic, and you can obviously transform it back to cubics and quadratics for exercise 4b and 4a as well. So the first question, this is a polynomial given to you. Step 1, I'm going to do what? I'm going to identify what my a is, b, c, d, and e. Okay, if you want to be doubly sure that you don't make mistake, you can write that down here, guys. A equals 7, b equals 6, c equals minus 5, d equals 4, and e equals 3. Okay, so what do you need to do, guys? What does the first thing, alpha, beta, gamma, delta, are the roots of this polynomial? You're going to find this. This is the sum of roots. Okay, you are having single root each time, so looking at the first 2 terms. This is plus, minus. You're going to be doing minus b over a, which is minus 6 over 7. Now, guys, you're doing 2 roots at a time. So this is in the short form, this is this. Okay, 2 roots at a time. So looking at first and the third term, first, second, third. Okay, and what do you do, guys? Plus, minus, plus. So this is c over a. That gives you minus 5 over 7. As simple as this. Okay, this is what we expect you to just remember. What are you doing? You're doing 3 roots at a time. So moving another term there, guys. This is the single roots. That's 2 at a time. This is 3 at a time. What sign? Plus from the first. Plus, minus, plus, minus. So d will be positive. That's a plus, minus, plus, minus. I'm sorry, I said d will be negative. It's minus d over a. Okay, so the answer d was positive 4. This is minus 4 over 7 is the answer. And for this one, the reciprocal one, really common. What you need to do is, guys, you have to make sure that you simplify like we normally do. Okay, the common denominator will be alpha, beta, gamma, delta. And as we multiply, guys, this on the top I get beta, gamma, delta for the first term. I get alpha, gamma, delta for the second. I get alpha, beta, delta for the third. And I get alpha, beta, gamma for the fourth one. And this is nothing but adding, taking 3 at a time, which is this one. So I just put this value on the top and put this value, the product of the roots, which would be plus, minus, plus, minus, plus. It will be e over a, so which is 3 over 7 at the bottom and minus 4 over 7 on the top. Simplify that. Okay, guys, so number 5, this one is cube of all of them. I'm going to take that whole of the cube outside. So this is nothing but product of the roots, which is last term, 1 term, 1 at a time, 2 at a time, 3 at a time, all 4 together. So plus is start with plus, minus, plus, minus, plus. This will be e over a whole cubed. So the answer is 3 over 7 cubed. So this is how you work out these questions. Now I'm going to move on, people, where we have to use the squares and the cubes of these roots, basic algebra. And I'll tell you to memorize certain formulas there to help you out to work on these questions, which will be exercise 4D then. Okay, starting with these two. You know, the square of a binomial is this, and cube of a binomial is this. You will learn this more when you do binomial expansion using Pascal's triangles and so on. What we can do over here, if you've been asked to find this in a polynomial, the roots, you're going to find square of these roots, guys. What do? You rearrange this to get alpha a plus b whole squared minus 2ab is equal to a squared plus b squared. Now if they ask you to find this bit, and when a and b are the roots of the equation, this is what the sum of the roots, this is what the product of roots, and you know how to find this from the equation. Don't confuse this a and b's with the a b's of your polynomial. I'm just trying to use a and b. I should have used pq maybe. So from here, if they ask you to find the cube of the two roots, okay, of something, but you can do what, guys? You can find this rearranging, take away minus 3a squared b minus 3ab squared, and what can we take common from here? This will be a plus b whole cubed, and I can take minus 3ab common. That gives me a plus b inside. So guys, look, is equal to a cubed plus b cubed. So if I have to find this for a quadratic equation, I know this is the sum of the roots, I know this is the product of the roots, I know this is the sum of the roots. So I can rearrange and put these values in from the polynomial. I can actually find this answer. Okay, similarly, there are lots of them given to you in the book, and it's better to learn them, find the pattern, identify them, and then use them in the questions. Okay, the next set of formulas, which are given on page 62, if your book is the same publication as mine, is the sum of squares. Alpha squared plus beta squared, we've done this on the top. Okay, this is what sum of the roots, take away the twice of product of the roots. Okay, if you want to find sum of squares of the three roots, it's similar pattern, guys. So we're going to do it here. We're going to do sum of the roots, alpha plus beta plus gamma whole squared, like we did over here. Sorry, like we did over here. Yeah, and then take away the twice of product of two roots, right? So twice of, and there'll be more than one product of two roots, twice of alpha beta plus alpha gamma plus beta gamma. Okay, so similarly we do this sum of squares of the four roots. It will be sum of roots again. So guys, see the pattern spotting I keep saying is a really important skill in A-level maths, guys. So sum of the roots again, then take away twice of, taking two at a time, and there'll be many possibilities. Alpha beta plus alpha gamma plus alpha delta plus beta gamma plus beta delta and plus gamma delta, guys, and this is the answer. You don't need to worry about all this. All you need to know is taking two at a time. This will be sigma alpha beta, and you know this is third term. So first term is a, then b over a will be this, minus b over a, then plus c over a will be this in the equation. Okay, so this is how we memorize the sum of squares. Similarly, we can do sum of cubes, and alpha cube plus beta cube has been done over there, which is equal to alpha plus beta whole cubed over there, and minus 3 times alpha beta, which is the product, okay, and times by alpha plus beta, which is the sum. So similarly, we can write the product of so sum of the cubes of cubic as well. Okay, and that's given the formula, that's given the book at page 63. You can copy that down, I mean, rather than me writing it down here. So guys, once again, spot the pattern, see how these roots are written like in this squares. I can just show you the pattern there. You do sum of roots square, take away, taking two at a time, twice of taking two at a time. Okay, That's how exercise 4D. We'll look at a couple of questions from here now. All right, so looking at question number 9 of exercise 4D. Look, guys, what does that mean? They're giving me the sum of roots, 1 at a time, sum of 2 at a time, sum of 3 at a time, and sum of 4 at a time. Okay, and they haven't asked me to find the equation, which they did probably in the 4C. Here they've asked me to find the values of these things. So what I'm expected to do, guys, I'm expecting to simplify this and somehow write in one of these 3 forms or 2 of these 3 forms or whatever. Right, so I haven't got a clue what we need to do, so we'll work together. What I'm trying to do is I'm going to try and multiply these brackets and see what do we get, and you do this as well. I'm going to pause the video and we'll match the answer. Idea is we're going to write in these forms, so we can put the numbers straight away. Okay, step 1, I've reached here. I've just multiplied these first 2 brackets. I multiplied the last 2 brackets. I've reached it. I'm going to try and multiply these as well. Obviously, they're going to get longer, but let's see where do we reach. So when I multiply first term of this bracket with all the terms of this, I've reached this stage. I'm going to multiply all the remaining terms for this one by one as well. Okay, let's see where do we get. All right, I multiplied the second term of this bracket with all of them. I've reached in these green terms. Okay, I'm going to do the same thing with the third term. Then I'm going to do the same thing for the last term. Let's see where do I get. So that's my third term, the beta with multiply with this. I'm going to multiply 1 and write all of them. Okay, so these are the 16 terms I get. I think it's 16, 4 times 4, 16. So guys, I'm going to write in these forms. I'm going to club them together so I can see some values. This is one I can see straight away. That is this. Okay, I'm happy about that. I can see the 3 term taking 3 at a time. That's 1, 2, 3, 4. The 4 terms with 3 at a time. Okay, I'll collect them. Then I'm going to take 2 at a time, guys. Here, that's 1, 2, 3, 4, 5, and 6. I'm expecting this 6. Okay, then there are single terms here, 1, 2, 3, and 4. I'm expecting 4 there as well. So let me rewrite it. Let me see what do we get, guys. Okay. Alpha, beta, and so on. Okay, I'll write it, then save the time of the video. Alright guys, so this is where I think I reached. This is one of the terms I need. That's this one. This is what taking 3 at a time. That's this one. This all 6 of them make together taking 2 at a time. That's this one. And this one is the sum of the roots taken 1 at a time. That's this one, and there's 1. All I'm going to do now, guys, I'm going to put the numbers in and find the answer. Okay, you can do it yourself. Now try this one as well. Okay, I'm not going to be do this increase the length of the video. I'll just work it out and you work it out as well first, then we match the answers. Okay, this is where I've reached. I've put a tick on 4, so these are the 4 terms I get when I multiply this bracket by 4. Green line of minus 2 beta, this is the 4 terms. I hope I've got this right. Red line is minus 2 alpha. When I times this by this bracket, I get these 4 terms. Then wiggly line of alpha beta, when I times by this, I get these terms. Check with my answer, then we rearrange them. Okay, this 16 is only number term. Then 1 at a time, of these 4 terms which have been underlined in green, arrange them with minus 8 common. That's what 1 at a time. Let me look at 2 at a time now. So when I club together taking 2 at a time, I got this 1, 2, 3, 4, 5, 6 terms. I'm going to write them together as well now. Moving on, when I collect taking 3 at a time, I got these 4 terms which are in the box. I'm going to write them together now. This is where I get, and the only term which has not been handled now is this one. So we write that in the end. So this gives you alpha, beta, gamma, delta. Because like I said, I mean, when algebra comes this neat, this should, look neat, and this should give you happiness to do this, guys. So you can see we got everything sorted and everything's what we wanted. This is what is taking 1 at a time. This is what is taking 2 at a time. This is what is taking 3 at a time. And this is what the product of roots is. Put the values in, find the answers. That's how we work out exercise 4D. I'm going to do the last bit now, guys. How do we transform the roots of the equation to write a new equation? Guys, this is Question number 5, exercise 4e. I'm sorry for this zooming in bit. Okay, sorry. Come on. Hope it gets better. So I like this sharpener, guys. What it is, look carefully. There's a polynomial or equation in variable x, which has roots alpha, beta, and gamma. And we're going to find an equation which has roots this. And we're not expected to actually solve this using calculator to find alpha, beta, and gamma, and then put these values in here to find the roots and write down the equations. Okay, we're not expected to solve this because that's what they say without solving. So guys, what do? We're going to be using this for all these roots. The new roots are linear transformations of this. These are the values of x, right? Let me see. These are the values of y. Okay, so y is the variable in which I'm going to write the new equation, is equal to 3 times the values of the roots of x, so I call them as an x, plus 1. So that is my transformation. This is my linear transformation. Okay, so what I'm going to do is I'm going to rearrange this to make x the subject. That gives me y minus 1 over 3 equals x. So people, what do? If I substitute this value for the x in the original polynomial and write a new polynomial in terms of y, that polynomial, the new one, will have these as the roots. Okay, so comes to algebra now. So this is, I'll leave that to you. We'll work it together. Pause it here. Substitute. I'll start you off. This will 3 times y minus 1 over 3 cubed plus y minus 1 over 3 squared, and so on, and then simplify this, work it out, and check the answer with mine. This is my first stage of expansion. I'm going to do what now, if I can cancel something down. Okay, this is where I reach. So my denominator, the biggest denominator at all sides is 9, so I'm going to do what, I'm going to times everything by 9 so that I get rid of all the denominators. So when I times everything by 9, I get to this stage, guys. All I need to be left now is just make it neater. That gives you y cubed, then minus 3y squared plus y is minus 2y squared, so minus 2y squared plus 3y minus 2y gives me 1y, plus 6y is 7y, so plus 7y here, then minus 1 plus 1 is 0, minus 51 is equal to 0. Guys, this polynomial will have these things as the roots, so I have to write the polynomial back in x. So guys, my answer would be x cubed minus 2y squared plus 7x minus 51 equals 0. Hope I've got my calculations right, otherwise you can check it yourself, guys. Okay, this is how we write new polynomial when your new roots are linear transformation of the previous one. Thank you very much, guys. This is the chapter. We've finished the video with this. Any more questions, let me know. We can work on it later. Happy learning, everyone. Bye-bye. Thing, guys, the question which I did, question number 5, was actually it was in the minus in the book over there, but I transferred it as a plus. Okay, so your answer might not match with the answer of the book, so use this question as an example and do that question yourself. Take this as a plus, then your answer will be, I think, hopefully what I've got over here. Okay, so that concludes the video, and you can try and do the question yourself.